Hello, and welcome back to Learning from Home. Today we are talking about the self-assessment that myself and Mr. Neil have put up on the new Google Doc. So really this is just a chance to take up the answers with actual explanations instead of just posting the answers and saying, have fun, hope you understand it. So, question number 1 says, which of the following is the correct restrictions on the variable x for f of x? Well, let's take a look here. We have x plus 3 over x minus 2, x plus 3, and hopefully you notice right away that there's an x plus 3 factor in the numerator and denominator. So they cross out, or they cancel out, and when they cancel out, they don't become 0. They're not nothing. They become 1. So we're left over with 1 over x minus 2. So you would think that our restriction would be, well, x can't equal to 2, because that's in the denominator, but we have to look at every single part of that function, even though we did cross out x plus 3 and it's now, in quotations, gone. At some point it was there. It's still a restriction on our function, so our answer is positive 2 and negative 3, which is A. For question 2, which of the following is equivalent to f of x? We have f of x equals to 2 bracket x plus 1. So let's take a look. In question A, we have 2x plus 2 over x plus 1. We could factor out the 2 in the numerator to get 2x plus 1 over x plus 1. We would see that the x plus 1's cancel out. We're just left with 2, so it's not A. Okay, in B, we have 2 bracket x plus 1, x plus 3 over x plus 1. Our x plus 1's cancel out, leaving us with 2x plus 3, which does not match f of x, so nope. For C, we can see that the x plus 3's cancel out, which means that we're left over with 2x plus 1, which matches exactly f of x, so our answer is C. You maybe noticed that right away, or you maybe went through all the options like me. Does it matter? And question 3, which of the following will be the widest parabola when graphed? When we're looking at the width, we're looking at stretches and compressions, so the A value. In A, we have an A value of 2, which is a stretch, a vertical stretch, so that's not super wide. In C, we have a vertical compression because we have a half there. Okay, so that's wider so far. So it's definitely not A. And in B, we have 1/2 x minus 2 all squared. So we want to definitely expand that. And we get 1 over 4 x minus 2 squared in our most simplified form. So we take a look at the new A value and looks like it's 1 over 4. So the widest parabola, or the most compressed graph, is going to be B. Awesome. Question 4. Simplify each of the following and state all necessary restrictions on the variables. So this is really just strictly algebra and practicing factoring skills. So remember that usually we look for factoring first. So starting with the one on the left here, factoring the top, we're looking for two numbers that add to 5 and multiply to 6. So right away we can put that as x plus 3, x plus 2. In the denominator, what I would do is notice that we can common factor out a 2 right away, make our lives a little bit easier. And then left over with x squared plus 9x plus 14. And with that, we still have to factor the denominator. We're not done yet. So we have x plus 3, x plus 2 all over 2. We leave that 2 there. We have to factor out that trinomial. So two numbers that add to 9 and multiply to 14. We got 7 and 2. So x plus 7, x plus 2. Look how nicely that worked out. we can see that the x plus 2, there's one in the numerator and one in the denominator, so they cancel it out to become 1. And our final answer is x plus 3 over 2 bracket x plus 7. And we have to state our restrictions. Maybe I'll do that at the top. So remember, for restrictions, we want to look at every single part. So every step. So looking at everything before we even cross stuff out, we see here that x plus 7 and x plus 2 are the two factors in the denominator, which would tell us that our two restrictions are x cannot equal to -7 and -2. So that's for the first one. Moving on to the second one, we have a whole lot going on there. We also have division. And remember, when we have restrictions, that we have to take a look at the denominator before, like at the beginning, and then after we switch it to multiplication. So maybe we'll start with restrictions first here and say that x cannot equal to 0, right? There's not really factors here in this case. We know that if x is 0, then the whole denominator is 0, which is not allowed. And we also see here if we had y as 0, then it would also cause division by 0, which is not allowed. So those are our two restrictions right now. I think a good place to start here, there's more than one way to approach this. Some people might like to flip it and turn it to multiplication right away. I think maybe we can simplify as much as we can right now before we do it multiplication. So I would say here we have x to the power of 6 and x to the power of 2 on the left fraction. Why don't we change that to x to the power of 4, right? Cancel out 2 of the x's. And with the y's here, we can say there's 3 y's in the top and 8 in the bottom. So we can cancel out all the y's in the numerator and change it to a 5 in the denominator. On the right side here, we have x squared in the numerator and x in the denominator. So I'm going to cancel out one of those x's there, make it a 1 in the top. And for the y's, we have y to the power of 2 and y to the power of 5. There are more y's in the denominator. So this is gone, and the denominator y changes to 3. We canceled out 2 of them, but there's still 3 left over. So let's rewrite that to make it look a little bit nicer. And we have -11 x to the 4 over 18 y to the 5 divided by 22 x to the power of 1, I don't really need the 1 though, over 3y cubed. And so now we are going to use our division strategy and change it to multiplication and flip the second one. 11x to the 4 over 18y to the 5 multiply by 3y cubed over 22x. So this is where we can do some cross canceling. Maybe I'll do it in green here. I would say -11 and 22, those numbers, remember we can match up a numerator and a denominator. So these two cancel out to be -1 over 2, right? Because 11 goes into 22 twice. And I would also say that we have x to the power of 4 here, and x to the power of 1 here in the denominator, so that's gone. Didn't want to do that. And that is gone, and that turns into x to the power of 3. Okay, we can keep going and say that there's a 3 over here in the numerator, and there's an 18 in the denominator over here. So 3 goes into 18 6 times, so there's a 6 left over. We got y to the power of 3 here, and y to the power of 5. So I'm going to turn that into a squared, because there would be 2 y's left over. This looks like a mess now, but let's put it all together nicely. So at the top we have the -1, x to the 3 times these all canceled out, so that's just 1. And in our denominator here, we're still left over with a 6. There's a y squared And there's also a 2 here, so 6 times 2, why don't we make that a 12 right away? So now we have 12y to the power of 2 in the denominator. So we multiply top times top, bottom times bottom, and we end up with negative 1x cubed, 12y squared, and we don't need to add any new restrictions, right? If we check through every step, even in our new flipped fraction over here, x still can't be 0, y still can't be 0 over here, so it is perfect. Okay, and lastly over here we have I would say this one's more challenging, right? It's because addition and subtraction requires that extra step of making a common denominator. But before we can make a common denominator, we have to, again, remember our first rule, which is to factor first. So we'll start here by repeating that left fraction. You can see our denominator is x plus 4. We need to factor over here. We can do 9 bracket x plus 9, or x plus 1 to see if anything cancels out. In the denominator here, we have to factor. Again, so two numbers that add to 5 and multiply to 4, well, that's going to be x plus 1, x plus 4. Wow, look at how nice this one turns out. Good thing we factored the numerator. And we can say that the x plus 1s cancel out, but it doesn't matter that we cancel it out. We still have to put it in our restrictions that x can't equal to negative 1 and also cannot equal to negative 4. Okay, so let's rewrite what we now have left over. We have x plus 3 over x plus 4, subtract 9 over x plus 4. Awesome. Do we have to make an extra common denominator? No, they're already common denominators now. Perfect. So now that they are common denominators, the whole point is that we can put it over one denominator. So x plus 3 subtract 9. Do I really need to put 9 in brackets? No, but I do want to have it in brackets if there was more things in that numerator. So it's a good habit to get into. Alright, so we want to collect the like terms there. X plus 3 minus 9 gives us x minus 6 over x plus 4. And that is as simplified as it can possibly get. So let's just maybe zoom out here for a second so you can see again all of the simplified answers. Hopefully that helps with your taking up your own answers. So question 5 is a graphing question, and I'm not going to spend too much time on it because we have taken up this type of question many times in class and it was on your last test, but it is a good practice, and I'm glad that we are revisiting this again and again because it wasn't super great, and it's just a good way to freshen up your skills. So what I really like, the reason I'm posting this here is so that you can actually just check your values to make sure that you graphed it properly and that it makes sense. So if we take a look at g of x here, you should have noticed that it was reflected in the x-axis, a vertical stretch, shifted to the right 1 and up 5 units. And based on the red image, that does make sense. If you want to check actual points, down below here, you'll see that I use the transformation map, and Mr. Neal's class I know has another method as well, which does essentially the exact same thing. So on the left are the original points of f of x is equal to x squared, and the red points are what they turn into, or the five main points on g of x. So you can double check that those are the same points that you got. The difference, or something to point out in h of x for the second question, oh no, is that yes, we have the k value of -2, which means that it is one reflected in the y-axis and a horizontal compression, which does make sense with the red picture that it's been kind of squished horizontally. But the mistake that everybody made on their quiz or test that was really just like a test to see if you could catch it is that usually k is in brackets or beside brackets, and the d value, like x minus d, is in its own separate bracket. And here it's not. It's -2x plus 6. and the negative 2 and the x are squished together. So really what you need to do there is factor out that k value so you get the real horizontal shift. So if you factor out that negative 2, like I have in purple here and red above h of x, if you factor out that negative 2, you're left with x minus 3 in the brackets. So even though it looked in the beginning that you had a shift to the left of 6, it's actually not. It's a shift to the right by 3 units. So that is a mistake that most of you would have made, and that's okay, because now you can fix that, go back, get your new points, and then check the answers again. And you would have also noticed that there is a vertical shift down too. So again, I'll scroll down and you can take a look and see the points and make sure that they match up with yours. Question 6 asks us to find the inverse function, f of inverse x. Recall that we are really just undoing. So if we look at this quadratic equation, we know that it doesn't really tell us anything. We don't know how to undo yet. There's multiple x's. It's way too complicated. So the first thing that we have to do is complete the square. So let's go ahead and do that. You're welcome to pause the video if you're doing this with me, or I guess check your answer, but we're going to complete the square. So let's recall that we have to first factor out that negative 3 from the first two terms. So I'm going to take that negative 3 out, and I'm left with x squared minus 6x plus 62. I already don't like that I put that in purple. Cool. All right, so then we see that middle term, that negative 6, we need to take that negative 6, divide it by 2, and square it. When we do that, we get 9. So that's going to be added and subtracted. So negative 3 x squared minus 6x, and that number we have to have plus 9, minus 9, in the brackets still, and that plus 62 stays on the outside. We'll deal with it later. The next step in completing the square is that we can do 2 steps in one if you'd like, but we're going to perfect square trinomial factor the first 1, 2, 3 terms here in the brackets. And when we do that, then we end up with negative 3. I'm going to keep that in a large square bracket. And from that factoring, we get the square root of the first term, which would just be x. The sign of the middle term, and the middle term is negative 6x, so the sign is negative, so we keep that. And the square root of the third term, so the square root of 9 is 3. And that goes in brackets squared. And we end up with negative 9 still hanging out there. Plus 62 at the end. But this doesn't look exactly like a quadratic vertex form yet. We are still waiting, and we need to get that negative 9 out of the bracket. So the last step that we have to do is take this negative 3 and multiply it by that negative 9 to get it out of the brackets. So that's going to end up looking like negative 3 x minus 3 squared. We wanted that negative 9 out of the brackets. So that's going to be negative 3 times negative 9, which is positive 27, plus 62. And our final step, we're almost there, is just to collect those like terms at the end, put that 27 and 62 together. I'm just going to put this in one color now. Negative 3x minus 3 squared plus 89. Awesome. So now we have it in the form where we can actually undo it and use our function machine. So if we're going to follow the path of our x, we would say, okay, well first x is over here and we have to subtract 3. After we subtract 3, then our whole new number gets squared. After that, it gets multiplied by negative 3. And finally, we add 89. So just like we do in class, again, this is kind of review, we're going to do the opposite. So our x now is going to have the opposite step, subtracting 89 divide by -3, square roots, plus or minus, don't forget that, that's an easy one to remember, and adding 3. And we're almost done now. We have to actually put it into our inverse function form. So it's no longer f of x, it's f of inverse x, which again is something that people forgot to include, that -1 there. F of inverse x is, well, what happens to x? First we subtract 89, divide everything by -3, take the square root, and finally add 3 at the end outside of the square root. And something you want to really make sure that you got is that when you take that square root, it's of everything, not just the numerator. So that division sign with -3 needs to be obviously clear that the square root is covering all of it. And that plus 3 needs to be on the outside, separate from that square root, because it is our last step. And there you go. So that should be you checking your answer for the inverse function question. Question 7. I love this question because I love working with radicals, and I know it irks a lot of you, but the more we practice it, the better that you get. Even the day before March break, you were getting a little bit better. So hopefully this is now a lot better. So just to remind ourselves, we need to, when we're trying to break apart these square roots and try to reduce them to their lowest terms, just like we do with fractions, right? We're always trying to reduce it to the lowest terms. We need to find the largest square number that goes into that number. So 162, for example, that's a tough one. You might have to play around with your calculator for a bit, and after you play around with it, you should have realized that it is now 81 times 2, make up 162. We'll move on to -5 times root 18. 18 is 9 times 2. And 98 is going to be 49 times 2. Now, does it matter that if you put 49 times 2 or 2 times 49? No, but I think it's just easier to put the square number as the first number. It doesn't matter though. So now we're going to break this apart, and we're just going to make an exactly equal line. It just looks a little bit different, and I'm going to say this 2 times, root 81 times 2 is the same thing as saying root 81 times root 2. All those things are still multiplied. I'm just breaking it up so it'll be easier to simplify. Same with here, 5 times root 9 times root 2 plus 7 times root 49 times root 2. So now all we're doing is just simplifying, right? The things that can be simplified. So root 81 is actually a whole number, so let's reduce it. Root 9 is actually a whole number, and root 49 is actually a whole number. So we're making it smaller. Is root 2 a nice number? No. If you put that in your calculator, it's a nasty decimal. So we're just going to leave it as exact as possible. So this now becomes 2 times 9 times root 2 minus 5 times 3 times root 2 plus 7 times 7 times root 2. So all we did was just make it more simplified. But we're not done yet. We have multiplication that we have to deal with. 2 times 9 is 18, so we have 18 times root 2. Notice how we can't put that number into the square root. It's separate, way separate. So 18 times root 2, that's the best that we can do right now. Minus 15 times root 2 plus 49 times root 2. Awesome, but we're not done yet, because what we should notice is that we have like terms now. These are all root 2's. We have 18 root 2's, subtract 15 root 2's, plus 49 root 2's. So how many root 2's are there in total if we gather all those like terms together? Well, 18 minus 15 is 3. 3 plus 49, 52 root 2, and that is the best that we can get. All right, question 8. Let's read this together. John Carlos Stanton holds a record for the hardest hit baseball ever recorded in a game. He hit the ball so hard that it was traveling off the bat at 195.96 kilometers per hour, about twice as fast as a car on the highway. Taking into account the angle of the hit, the height of the ball can be modeled with the following function. H of t equals negative 4.9 t squared plus 3.1 t plus 0.2. Our goal is to find the domain and range. So that's a tricky one. There's a lot going on there and a lot of information that's just there for fun facts. So if we picture a parabola, so there's our x and y, or in this case, our t and our h of t. Right, we know that it's a parabola that's facing down because it has a negative a value. So it's going to look something like this, and just for fun, we'll extend it backwards. It obviously doesn't make sense to have this negative part here usually in word problems, but we'll extend it back so we can fill some stuff in later. So there's our parabola for now. So with our domain and range, obviously we know with a regular parabola we would say that x is any real number, but that doesn't make sense in this word problem. So we are trying to figure out what angle and height for our domain and height for our range. So we know that just visually here it needs to be for our domain between 0 and something, and for our height again it needs to be between 0 and something. So let's take a look. So I kind of went ahead and did this for you just to save some time, but really we want to know if we want to try and figure out where this point right here is, right, to help us out with our domain, right, where our x values exist, then we're trying to see, well, the zeros, and the easiest way to do that with all these decimals is the quadratic formula. So reminding ourselves that it's x equals, or in this case t equals, negative b plus or minus the square root of b squared minus 4ac all over 2a. Fill in your a, your b, and your c, and you can check your answer here. And we end up getting two answers, one being negative 0.06 and one being 0.69. We can fill that in on the graph up here, 0.69, negative 0.06, right? It helps to have a visual. But this one doesn't really make sense. So when we're looking back at our domain, we know, okay, this is probably the answer that we want to help us make some sense of the situation, right? Normally it tends to be the positive one. You'll see it in the lesson a couple of days from now, if you take a look at that video, when you have to reason a little bit differently when they're both positive. Anyways, to find the vertex, you could go back and complete the square, totally valid, and if that's what you did, that's awesome. Another method is, since you already did all this work to find the two x-intercepts, you can find the average between them, right? Find that middle point, since we know our vertex is in the middle, since a parabola is symmetrical. So it's usually x equals r plus s divided by 2. Doesn't really matter if you have a formula, really, if you can go to that second step and add them together, divided by 2, finding the average of them. You get 0.315, which on our picture would be, if this is our vertex up here, that would be that 0.315, right? That kind of halfway point in between your two zeros. How do we get that max height, which is going to be important for our range? Well, you have to plug it back into your equation. So that would be right here, h of 0.315. Well, we plug that in for every single x, and we end up getting 0.69 meters. So let's go up here for a second, and we can label this here as 0.69 meters. So now it's time to actually give ourselves a domain and a range. So domain, we know that we're using t instead of x, so it could be any real number, but it's probably going to be between 0 and the other t-intercept that we found, which is 0.69. That makes sense because our graph only really exists between those 2 points, 0 and 0.69. For the range, you can say h is any real number, but where does h exist? So we know what the height is as low as 0 here because it touches the x-axis. And how high does it go? Well, we found the maximum, so that tells us that our height can be anywhere between 0 and 0.69. That's funny how that ends up working out to be pretty much the same decimal. Anyways, those are the answers for your domain and range. Question 9, another word problem, another application. Let's read it together. Calculators are sold to students for $15 each. 75 students are willing to buy them at that price. For every $5 increase in price, there will be 5 fewer students willing to buy the calculator. You guys are pretty awesome at this question, at least from what I've seen. So this should have been pretty nice when you were trying it out, but let's take it up together. I think a good strategy with the question like this, whether it's a price increase or a price decrease, is that we kind of split it up into those two categories of one being items or people or whatever, and the other one being money. So I'm going to highlight all the money things in this reddish color, pinkish, whatever. So $15 each and $5 increase. And in blue, we'll do the people, 75 students, and end up being 5 fewer. Cool. So I'm going to keep making a note off to the side as a let statement that we usually do for word problems. Maybe that's a grade 10 thing, but it is important to let your reader know what is your X representing, and it's important for you to understand that too. So we say let X represent the number of $5 increases. So X is just telling us if X is 1, it's increased 1 time. If X is 2, it's increased 2 times, and now it's $10, right? But it's telling us how many times it increased. So we're going to set up our f of X. I guess it's revenue, right? This is a revenue question, so let's call it R of X. And we're going to have 2 brackets here. And one is going to be for money, and one is going to be for people, or sometimes it's items. So we kind of always start with the original thing. What did we start with? So calculators are sold to students for $15 each. That's our original price. It's going to go in the beginning of the bracket. People, well, there's 75 students are willing to buy them at the original price. So 75 is going to go at the beginning of that bracket. Then for every $5 increase in price, so the price is increasing, so we're going to have a plus sign, $5 per every increase. So X is our number of increases, $5 per increase, perfect. In terms of people, there's 5 fewer students, it's less, so we're going to subtract 5 per increase, subtract 5X. Awesome. So what selling price will produce the maximum revenue? So maximum tells me right there, sounds like the vertex. Right, that's a big hint. Maximum, minimum, those are points that mean optimal. So we want to find the vertex. Well, we're already in a factored form. You could expand it and you could complete the square if that's what you're really comfortable with. But the easiest way here is to take both of our factors that are already there, set them equal to 0. So I would say 0 equals to 15 plus 5x. And 0 equals 75 minus 5x. And we're trying to find out, well, what is x? So if we solve for this, we get negative 5x equals 15. X is negative 3. 5x is equal to 75. And x is equal to 15. So we're not done yet. Those are just our 2 opposite zeros, right? We're trying to find the maximum. We need the vertex, which means that we need the middle of those 2. So we'll just keep going over here. X is r plus s divided by 2. We want the middle. 15 minus 3 divided by 2, which is 12 divided by 2, which is 6. So this right here is telling us 6 price increases. Okay, not that the price is $6, it's just telling us 6 price increases. This question is saying what selling price will give us the maximum revenue? Well, if we go back to our original equation, we said that price was equal to 15 plus 5x. So let's just put that over here. Price is equal to 15 plus 5x. But you just found out that x is 6. So 15 plus 5 times 6. So 15 plus 30, which is 45. So what is this telling us here? That $45 as your price for a calculator maximizes revenue. Okay, that's exciting. Now we know that $45 as a price for our calculator maximizes the revenue. That's part A done. Part B is saying, what is the max revenue? Well, we already know the X value that gives us the max, so we just have to take this X value there and plug it in to our original. So we're basically trying to find R of X, R of 6. So revenue at 6, price increases, is 15 plus 5 times 6, which we already just found, but that's okay, times 75 minus 5 times 6. So we already found out that this bracket was 45. Here we have 75 minus 30. 45, put it together. 45 times 45 is 2025. So therefore, the max revenue is $2,025. Okay, our final question. 10 says to find the specific function with roots -1 plus root 2 and -1 minus root 2 that passes through at point -3, 2. So I already wrote in some of this for you, but we will talk it out together. So you want to start with the factored form equation of the quadratic function. Remember, you have 3 choices: standard form, factored form, vertex form, but since you are given 2 roots, then you might as well use the 2 roots that you're given. So there's factored form, your R and your S, so you can substitute in those 2 points for your R and your S. Notice that I put them in brackets because you are subtracting the entire thing, and you need to recognize that that subtraction goes to everything in the bracket, which is how we get to x plus 1 minus root 2 and x plus 1 plus root 2, right? This negative times negative makes positive, and same here. So without that bracket, you will probably miss that last square root sign changing, which is kind of important. Okay, and we leave that A there because we don't know what A is yet. That's the goal. So our next step is, now that we put in the 2 roots, is that we have to use the point that they gave us in the question. They gave us a point -3, 2. Well, that's an xy coordinate. So here's your x and there's your y. You substitute -3 in for every x and 2 in for every y. As I'm talking this out, I know that you have shown me in class multiple times that you can handle this type of question, so hopefully it went well. Anyways, so here we go, substituting in 2 for y and -3 for x. You can, with this blue underline here, you can see that we can still collect like terms before we start multiplying anything. It'll be too tricky if you don't. So you put the -3 plus 1 together, you get -2 minus root 2 and -2 plus root 2. Those are 2 brackets multiplied together with 2 terms each, so we need to FOIL, right? There's our purple line showing the double rainbow, the FOIL. And when you expand that, you get 4 minus 2 root 2 plus 2 root 2 minus root 4. So that's testing your knowledge of when you multiply 2 roots together, you multiply the numbers underneath the root sign. Luckily for us, it worked out so nicely, and -2 root 2 plus 2 root 2 cancel each other out, right? They're opposite. When you collect like terms, you get 0. So we're left with 2 equals a bracket 4 minus 2. Where did this 2 come from? Well, root 4 and 2 is the same thing, right? Simplified. 4 minus 2 is 2, so we have 2 equals a times 2. We're almost at the end here. We know we can divide both sides by 2 to balance it out, get our a by itself. A equals 1. Feels like you're at the end, but you're not done yet until you answer the question. And the question says, find the equation. So when you just put it all together in the equation, put your a back in. Obviously, it's kind of like you have that invisible 1 there. You don't really need that there. But just to show you that's where it came from, you did all that work to find a, and it just ended up being 1. Oh well. So f of x is equal to x plus 1 minus root 2 and x plus 1 plus root 2. You could leave it like in your very first form when you put it in with brackets, but there's no point. Make it as simplified as possible. And that's the smiley face because you are now done. Great job.